Okay, thank you for joining everyone. My name is Nikos and I will be talking about shifting security left in a development lifecycle and how to do that efficiently. A few words about myself in the beginning. I am a holder of the Certified Software Security Lifecycle Professional certification by ISC2, and also I'm a holder of Master of Science in Information Technology. I have worked in the past as a developer, and at some point I transitioned into application security. So I combine the two things I love. I still do some Python coding, and I have a couple of open source projects that I contribute to. In the past, I was one of the leaders of the OWASP local chapter in Stockholm. I occasionally blog in appseguide.se. And of course, things I like working with is structuring application security life cycles, improving those, doing threat modeling for products and applications to identify potential vulnerabilities, working, of course, with securing software architectures, identifying, detecting product vulnerabilities, mitigating those, and delivering security training to development teams. And this presentation has been created based on my experiences and the experiences that I have with me, having worked in several areas and companies, having different roles in broadcasting, digital healthcare, finance, and so on. So I asked ChatGPT to create an image for me, using my own words to describe how I see the software development process, and this is what it created. And I think it captures quite a few bits that I have been thinking about. So the classical example of product creation is more of a forward line thing where each phase is adding some value, and then you're shipping a final product, and that's it. Maybe you never see that product again, but that's not the case with software development, right? It's more of a continuous process, a continuous improvement process. You cannot just land the software airplane whenever you want. Errors, vulnerabilities will cause problems, operational with flight, but also will cost money because we have to land the airplane and fix the software airplane before it can fly off again. And the worst case scenario, you will get really serious problems if vulnerabilities or the bugs are really big. So with that image in mind, what we have done so far in the software industries, in the beginning, we had maybe a couple of security people who should be a know-all kind of person. They have limited responsibilities, and then they try to fix all the problems, but that didn't scale. And what we tried to do here is to try and shift the security work as close to the development teams as possible, and as early in the development process as early as possible. More or less following the same principle for fighting with fire. So we need to catch bugs and problems early, because if the fire evolves, that will become a problem. It will be more costly to fix that later on when the fire has evolved, but it's going to be relatively easy to deal with the fire if you detect it early. And the same principle, of course, applies to software vulnerabilities. Way easier to fix while coding, much harder to fix when a product has been shipped to the final customers. And what does shifting left looks like? What are we actually shifting left? Here's a very simplistic example of components of a security development lifecycle. So we have secure code training, which is making sure that our developers know how to mitigate vulnerabilities. We have static application security testing, SAST, as it's usually referred as, which is using automated tools to detect vulnerabilities in source code, software composition analysis, which is about identifying vulnerabilities in the open source components that we are using in our products, and of course container scanning to detect vulnerabilities in our Docker containers, infrastructure as code configurations, because how to set up infrastructure, if you define it as code, it is also a development task, and that needs to be checked for security. There is dynamic application security testing tasks, which aim at using automated tools to detect vulnerabilities in a functional near-to-end product or final product. And of course, penetration testing, which is something we do for critical applications in order to identify vulnerabilities. So we bring in an external independent tester, and we test the application for vulnerabilities. And as we said, this list of tasks needs to happen as early as possible, and usually in, at least if we map that early phases to the DevOps cycle, that is during planning and coding phases. So security requirements, SCA, SAST, infrastructure scanning, container scanning, all those are going to happen as early in the process, catch the problems soon enough to be able to fix them fast and without those vulnerabilities costing a lot. However, although that process is self-explanatory in most part, it becomes a problem. It becomes a problem for the development teams, because not only do they have to deal with their regular line of work, but they also now have the security work as well on their shoulders, and that's a big weight to carry. So what I've done and what I'm trying to communicate with this presentation is that there are ways, which I've grouped in 3 guidelines here, to improve the SDLC process and make it a more efficient process for the development teams so they can deliver faster, better code, making everybody happy, ourselves as security professionals, because we get vulnerabilities fixed, themselves because they have a functioning process that they can affect and contribute to. So the 3 guidelines is basically don't think in silos. The SDLC process, securing the SDLC process is not to be thought of as siloed columns, processes, for example, SAST box and then a DAST box and a training box that never talk to each other. On the contrary, it's a continuous process, and we're going to look at some practical examples about that. And then we have the picking the right tools and processes. Not every tool is for everyone, and we really have to be picking the tools after a lot of testing and making sure they fit our needs and our culture. And of course, the SDLC is not a one-time effort. It's a continuous process. And we'll talk about that as well in a couple of slides. Starting from breaking the silos and picking secure code training as an example. Usually what we do is that we go to the development teams and we say, hey, we have this really good digital platform for secure code training. So I would like you to go in and complete these 5 courses so you become a better coder and you can actually write more secure code for our company, right? This is the classical scenario, the common scenario. The thing is that when a developer reads about, let's say, cross-site scripting, and then 6 months later, they get a vulnerability actually from, we assume, a SAST analyzer about cross-site scripting, it's a bit hard to connect those 2 parts. It's a bit hard to go switch platform, go find cross-site scripting material. Maybe you don't remember where those things are. Go through these and then jump back to the SAST finding. It becomes a little bit hard to work with. So just-in-time learning is an excellent example of how to connect your automated analyzers with training. If you provide that training during the analysis, when the finding is shown to the developer, and you can actually watch the cross-site scripting learning material when the vulnerability is found, that gives you a lot of benefits in terms of time savings. And this can be done with SAST analyzer, this can be done with dust analyzers, and it really gives you this continuous process, and it bakes in training in other parts of the SDLC. That's not to say that you should not offer digital platforms so that people can log in and watch material whenever they want to, and they want to evolve. But it's on the contrary saying that it's really beneficial to connect that with findings as well, because that's going to result in a lot of benefits. Threat modeling is another example where, for example, I used to do that mistake. I used to think of threat modeling as a separate box, and we create material for the development teams to work on in the future or in the coming iteration, and then we forget about it, and maybe we take it again next 6 months or in a year. But the thing is that there are more parts in this process, such as penetration testing, that can benefit from findings in threat modeling. And finally, we have the example of SAST and dust analyzers, those tools, they also create a lot of findings, really valuable tools. They can improve a particular version of your product, but if we take that knowledge of the types of vulnerabilities we are introducing and how we're fixing, and we generate requirements and learning material, and we propagate those in the company, then we also have a loop there that improves our efficiency to faster detect vulnerabilities in the future. So obvious benefits, it's becoming a continuous process by breaking the silos. We have tremendous time savings and also increased efficiency in detecting and fighting vulnerabilities. Using the right tools and processes. Not every tool is for everyone, and finding the right tool is crucial. As an example, static code analyzers, some come with an AI assistant, which can potentially be very beneficial for the developers, because not only do they get a lesson saying that this is how, in general, you could mitigate this cross-site scripting vulnerability that you're being shown in this page, but also they come with code, actual code that mitigates that vulnerability for your specific applications, and this is tremendous in efficiency and time savings. The same applies for software composition analysis and open source security, when reachability analysis, as it is usually called, can tell you, is the vulnerable functionality in the open source component that you're using actually going to cause a problem in your product or not, so you can better plan and work on the vulnerability or not. And of course, the same principle applies for processes. You need to find those processes that give you the value and, of course, time efficiency, and increase engagement from your development teams, because now they feel they're part of a process. And finally, maybe the most self-explanatory of all, continuous improvement. You need to think of your SDLC as a continuous improvement process. Think of your culture, ask the development teams, get feedback, and build that in, bake that in your SDLC, so you get the developers being part of that, and you build a more efficient SDLC. Build those feedback loops for tools and processes as well. And with that, I conclude my presentation. In summary, the three guidelines where break the silos, pick the right tools and processes, and of course, continuously evaluate and listen to your development teams. Thank you very much.